Waveform Audio File Format is a Microsoft and IBM audio file format standard for storing an audio bitstream on PCs. It is an application of the Resource Interchange File Format bitstream format method for storing data in chunks, and thus is also close to the 8SVX and the AIFF format used on Amiga and Macintosh computers, respectively. It is the main format used on Windows systems for raw and typically uncompressed audio. The usual bitstream encoding is the linear pulse code modulation format. Description: both WAVs and AIFFs are compatible with Windows, Macintosh, and Linux operating systems. The format takes into account some differences of the Intel CPU such as little-endian byte order. The RIFF format acts as a wrapper for various audio coding formats. Though a WAV file can contain compressed audio, the most common WAV audio format is uncompressed audio in the linear pulse code modulation format. LPCM is also the standard audio coding format for audio CDs, which store 2-channel LPCM audio sampled 44,100 times per second with 16 bits per sample. Since LPCM is uncompressed and retains all of the samples of an audio track, professional users or audio experts may use the WAV format with LPCM audio for maximum audio quality. WAV files can also be edited and manipulated with relative ease using software. The WAV format supports compressed audio, using, on Windows, the Audio Compression Manager. Any ACM codec can be used to compress a WAV file. The user interface for Audio Compression Manager may be accessed through various programs that use it, including Sound Recorder in some versions of Windows. Beginning with Windows 2000, a WAV format extensible header was defined which specifies multiple audio channel data along with speaker positions, eliminates ambiguity regarding sample types and container sizes in the standard WAV format and supports defining custom extensions to the format chunk. There are some inconsistencies in the WAV format. For example, 8-bit data is unsigned while 16-bit data is signed, and many chunks duplicate information found in other chunks. Specification: the WAV file is an instance of a Resource Interchange File Format defined by IBM and Microsoft. RIFF: a RIFF file is a tagged file format. It has a specific container format that includes a 4-character tag and the size of the chunk. The tag specifies how the data within the chunk should be interpreted, and there are several standard FOURCC tags. Tags consisting of all capital letters are reserved tags. The outermost chunk of a RIFF file has a RIFF form tag. The first 4 bytes of chunk data are an FOURCC that specify the form type and are followed by a sequence of subchunks. In the case of a WAV file, those 4 bytes are the FOURCC wave. The remainder of the RIFF data is a sequence of chunks describing the audio information. The advantage of a tagged file format is that the format can be extended later without confusing existing file readers. The rule for a RIFF reader is that it should ignore any tagged chunk that it does not recognize. The reader won't be able to use the new information, but the reader should not be confused. The specification for RIFF files includes the definition of an info chunk. The chunk may include information such as the title of the work, the author, the creation date, and copyright information. Although the info chunk was defined in version 1.0, the chunk was not referenced in the formal specification of a WAV file. If the chunk were present in the file, then a reader should know how to interpret it, but many readers had trouble. Some readers would abort when they encountered the chunk. Some readers would process the chunk if it were the first chunk in the RIFF form, and other readers would process it if it followed all of the expected waveform data. Consequently, the safest thing to do from an interchange standpoint was to omit the info chunk and other extensions and send a lowest common denominator file. There are other info chunk placement problems. RIFF files were expected to be used in international environments, so there is CSET chunk to specify the country code, language, dialect, and code page for the strings in a RIFF file. For example, specifying an appropriate CSET chunk should allow the strings in an info chunk to be interpreted as Cyrillic or Japanese characters. RIFF also defines a junk chunk whose contents are uninteresting. The chunk allows a chunk to be deleted by just changing its FOU or CC. The chunk could also be used to reserve some space for future edits so the file could be modified without being rewritten. A later definition of RIFF introduced a similar PADA chunk. RIFF Wave. The top-level definition of a WAV file is Waveform RIFF, Wave, FMTCK format, Fact CK Fact chunk, QCK Q points, Playlist CK playlist, ASIC data list associated data list, Wave data Wave data. The definition shows a top-level RIFF form with the wave tag. It is followed by a mandatory FMTCK format chunk that describes the format of the sample data that follows. The format chunk includes information such as the sample encoding, number of bits per channel, the number of channels, the sample rate. The WAV specification includes some optional features. The optional fact chunk reports the number of samples for some compressed coding schemes. The Q-point chunk identifies some significant sample numbers in the WAV file. The playlist chunk allows the samples to be played out of order or repeated rather than just from beginning to end. The associated data list allows labels and notes to be attached to Q-points. Text annotation may be given for a group of samples. Finally, the mandatory wave data chunk contains the actual samples. Note that the WAV file definition does not show where an info chunk should be placed. It is also silent about the placement of a CSET chunk. The RIFF specification attempts to be a formal specification, but its formalism lacks the precision seen in other tagged formats. For example, the RIFF specification does not clearly distinguish between a set of subchunks and an ordered sequence of subchunks. The RIFF form chunk suggests it should be a sequence container. The specification suggests a list chunk is also a sequence. A list chunk contains a list, or ordered sequence, of subchunks. However, the specification does not give a formal specification of the info chunk. An example info list chunk ignores the chunk sequence implied in the info description. The list chunk definition for wave data does use the list chunk as a sequence container with good formal semantics. The WAV specification allows for not only a single, contiguous, array of audio samples, but also discrete blocks of samples and silence that are played in order. Most WAV files use a single array of data. The specification for the sample data is confused. The wave data contains the waveform data. It is defined as follows: wave data a data CK data list, data CK a data, wave data, wave list a list, wave data CK wave samples, silence CK. Silence CK a SLNT, DW samples, DWORD count of silence samples. These productions are confused. Apparently data list and wave list should be identical. Even if the problem is fixed, the productions then allow a data CK to contain a recursive wave data. The specification should have been something like wave data a data CK wave list, data CK a data, B sample data, byte. Wave list a list, wave data CK wave samples, silence CK. Silence CK a SLNT, DW samples, DWORD count of silence samples. To avoid the recursion, WAV files can contain embedded AIFF lists, which can contain several sub-chunks. Metadata, as a derivative of RIFF, WAV files can be tagged with metadata in the info chunk. In addition, WAV files can embed extensible metadata platform data. Applications may not handle this extra information or may expect to see it in a particular place. Although the RIFF specification requires that applications ignore chunks they do not recognize, some applications are confused by additional chunks. Popularity: uncompressed WAV files are large, so file sharing of WAV files over the Internet is uncommon. However, it is a commonly used file type, suitable for retaining first-generation archived files of high quality, for use on a system where disk space is not a constraint, or in applications such as audio editing, where the time involved in compressing and uncompressing data is a concern. More frequently, the smaller file sizes of compressed but lossy formats such as MP3 are used to store and transfer audio. Their small file sizes allow faster internet transmission, as well as lower consumption of space on memory media. There are also lossless compression formats such as FLAC. The usage of the WAV format has more to do with its familiarity and simple structure. Because of this, it continues to enjoy widespread use with a variety of software applications, often functioning as a lowest common denominator when it comes to exchanging sound files among different programs. Used by broadcasters, in spite of their large size, uncompressed WAV files are sometimes used by some radio broadcasters, especially those that have adopted a tapeless system. BBC Radio in the UK uses 44.1 kHz 16-bit 2-channel WAV audio as standard in their VCS system. UK commercial radio company Global Radio uses 44.1 kHz 16-bit 2-channel WAV files in the Genesis playout system, and throughout their broadcast chain. The ABCD cart system, which was developed by the Australian broadcaster, uses 48 kHz 16-bit 2-channel WAV files, which is identical to that of digital audio tape. The Digital Radio Mondiale Consortium uses WAV files as an informal standard for transmitter simulation and receiver testing. Limitations: the WAV format is limited to files that are less than 4 GB, because of its use of a 32-bit unsigned integer to record the file size header. Although this is equivalent to about 6.8 hours of CD-quality audio, it is sometimes necessary to exceed this limit, especially when greater sampling rates or bit resolutions are required. The W64 format was therefore created for use in SoundForge. Its 64-bit header allows for much longer recording times. The RIFF64 format specified by the European Broadcasting Union has also been created to solve this problem. Non-audio data: since the sampling rate of a WAV file can vary from 1 Hz to 4.3 GHz, and the number of channels can be as high as 65,535, WAV files have also been used for non-audio data. Spice, for instance, can store multiple circuit trace waveforms in separate channels, at any appropriate sampling rate, with the full-scale range representing A plus or minus 1 V or A rather than a sound pressure. Audio CDs do not use the WAV file format, using instead Redbook audio. The commonality is that both audio CDs and WAV files encode the audio as PCM. WAV is a file format for a computer to use that cannot be understood by most CD players directly. To record WAV files to an audio CD, the file headers must be stripped and the remaining PCM data written directly to the disk as individual tracks with zero padding added to match the CD's sector size. In order for a WAV file to be able to be burned to a CD, it should be in the 44,100 Hz, 16-bit stereo format. WAV file audio coding formats compared. Audio in WAV files can be encoded in a variety of audio coding formats, such as GSM or MP3, to reduce the file size. This is a reference to compare the monophonic audio quality and compression bit rates of audio coding formats available for WAV files including PCM, ADPCM, Microsoft GSM 06.10, CLP, SBC, TrueSpeech and MPEG Layer 3. The above are WAV files. Even those that use MP3 compression have the WAV extension. See also, comparison of audio coding formats, Audio Compression Manager, Broadcast Wave Format, RF64, an extended file format for audio, notes. References. External links, WAV file format specifications, from McGill University, a summary of the WAV file format. WAV format extensible specification from Microsoft, more information on WAV format extensible, University of Bath, WAV file format, technical details, WAV and BWF metadata guide.